In the previous class, we were talking about heat, mainly propagation of heat and effect of heat is what we had discussed. And today we will continue from there. We will be talking more about propagation and heat factor. Just sharing the screen. My, yes. Now, yesterday we also talked about sea breeze and land breeze. What is sea breeze? What is land breeze? And all. Okay. Now, 10.5 properties of clothes we wear in summer and winter. Now, what color clothes do you prefer to wear in summer? I'm all black. Yeah, I get it that black is a trend. But if you have observed that black color means some things make you feel more hot compared to white. If you have gone out in boat on a very hot summer day, you must have noticed that or noticed this as an activity. Go out on a very hot summer day, one day while wearing white and one day while wearing black. And then you can see what happens. Okay. What you will observe that when you are wearing dark color clothes, okay, you might feel a little more hot, okay, a little bit more hot compared to when you are wearing light color clothes. Okay, there is some reason behind that activity. And also in winter, when we go out in winters, we see that we all wear black jeans, black jackets, brown jackets, or mostly dark colored clothes, right? Dark colored jeans and dark colored jackets and sweaters we are wearing and going out. Okay, there is some reason behind that too. Okay, now when we are wearing light color clothes, okay, light color clothes, they absorb less heat. They absorb less heat. Light color clothes absorb less heat compared to dark color clothes. Okay, in comparison to dark color clothes. That is why when if in summers we wear dark colors, they trap more heat, making us feel more hot. Okay. And whereas in winters, why should we wear dark color clothes is because they will trap the heat and make us feel warm compared to the cold surroundings. Okay. They will make us feel warm compared to the cold surroundings because they trap more heat. Whereas light color clothes trap less heat and allow it to pass through them. Okay. Allow air to pass through them easily, whereas dark color clothes do not. So that is why light color clothes are preferred in winter and dark color clothes are preferred in light color clothes are preferred in summer and dark color clothes are preferred in winter. Okay, now in the winter, we use woolen clothes. Wool is a poor conductor of heat. Moreover, there is air trapped between the wool fibers. Okay, another reason is this. Uh, Wool is a bad conductor of heat. Okay, and there is air that is trapped between the wool fibers. And this air, which gets trapped between the wool fibers, prevents the flow of heat from our body to the cold surroundings. Okay, they prevent the flow of heat from our body to the outside surroundings. We keep the heat trapped. Okay, they keep the heat trapped, making us feel more warm. Okay, suppose you are given the choice in winter of using either one thick blanket or two thin blankets. What would you choose and why? One thick blanket or two thin blankets? Okay. Remember that there would be a layer of air between the blankets. It is therefore said that in winter, one should be dressed in layers instead of single thick cloth because they trap air between them and do not allow the heat to escape. Okay, the layers do not allow the heat to escape. Okay, so we should dress up in layers in winter. Okay, layers. Do you remember, like in childhood, how many of your mothers used to dress you in 3 layers, 4 layers, 5 layers? Do you remember that? Wearing 3 layers, 4 layers, 5 layers as a child. Okay, many of the layers. But when we grow up, we prefer to wear lesser layers, maybe 1 or 2 layers we wear, 2 layers, 3 layers. But when you observe little kids, they wear 4 layers and 5 layers, okay, and so on. But that is good. Okay, the more the layers, the better heat trap allows us to feel warm. Okay. Questions? Any questions related to this? No. Eva Abidja, videos on please. Can I have your videos on please? Fill in the blank. Yeah. In-text questions 10.2 is homework for you today. Okay. Science homework for you today is in-text question 10.2. Combustion. Now, the process of burning is called combustion. Simple as that. Burning is known as combustion. Okay, the process of burning is called combustion. Now, combustion, that is burning, is a chemical process. We have studied this so many times. We've been studying this, that burning is a chemical process. Why? Why is that so? Because a substance, okay, is reacting with oxygen to produce heat, right? Have you ever observed that when we are lighting up a bonfire or some fire, okay, we put the coal or the wood and then we just blow it with some, cardboard or something, which fan it, and then the flames become stronger. Have you observed that, seen that happen? It is fanned and then the flames grow. Why is that happening? Why the heat is become spreading when the air is, you know, blown to it? The reason is that when more stronger air is blown, the material burns more furiously, okay, more deeply, more, it spreads more. The heat spreads more and it burns more with more intensity, okay, when you fan a flame, okay. So that such process is combustion only, okay. The air, the substance that's burning reacts with the air and burns more, okay. Now, the substance which undergoes combustion, okay, the substance which goes through a process of combustion or which burns is called fuel, okay. The substance that undergoes combustion is called fuel. Now, some materials burn with a flame like a candle, and some materials burn without a flame also, like coal. Okay, coal burns without a flame, candle burns with a flame. Now, the substance that undergoes combustion easily and produces heat, the substance which can easily be burned and produce heat, is known as combustible. It is said to be combustible. Now, different substances catch fire at different temperatures. Different substances catch fire at different temperatures. What does that mean? What does that mean? When you burn paper, okay, at a very low, you can say at a very low flame also, very small candle flame, it will burn up quickly, right? When you put a paper on a candle flame, it will burn up quickly. Whereas when you will take dry wood, okay, dry wood sticks and all, and then try to burn it. Okay, if it is wet wood, it will not burn. But if it is dry wood and dry leaves, you will notice that it does not start burning immediately like a paper. It will take some time, right? It will take some time. It will take you 2 to 3 attempts to put fire in it. and then get it burning, right? So that is what, like why paper is burning so quickly, whereas wood and other things are taking so much time to burn. Okay, that is because they have something known as ignition temperature. Okay, there is something called ignition temperature, and it is the lowest temperature at which a substance catches fire. Okay, it is that lowest temperature at which anything catches fire. And this temperature, the ignition temperature, is different for all substances. Okay, ignition temperature is different for paper, it's different for wood, it can be different for a car. Okay, so it is different for different things. Ignition temperature is different. Okay, understood what is combustion, what is a fuel, what is combustible material, and what is ignition temperature? Did you understand all of that? Yes or no? Any doubt in any of it? This part, this panel, any doubt in this panel? No? Okay then. Now, there are three conditions required for fire to take place, for combustion to happen. Okay, there are three things important for a fire to happen, for combustion to happen. What are they? The first is heat. Okay, heat. Ignition temperature must be within access. Okay, like ignition temperature must not be such that you are burning but it's not getting burned. Okay, it should be accessible. It should be to a limit that it will start a fire after some time or maybe a few minutes or seconds. Okay, so heat is necessary. Heat. Okay, then fuel. Fuel that is, that can burn. Fuel that can burn, called combustible. Fuel that can catch fire. Fuel that can burn, called combustible. Okay. Then oxygen. Suitable amount of oxygen or air should be there. Okay. Suitable amount of oxygen should be present. So when these three conditions are there, okay, anything catches fire. When these three conditions are there, anything catches fire. Heat, something to burn, and air. Okay. Fire, something to burn, and air. These three things are the conditions necessary for combustion to take place. Now, understood what are the conditions for combustion? Any doubt in combustion topic? No. Okay. Now we will talk about the flame. Okay. We talk about the flame. The substance which vaporizes during burning gives flame. Okay. Becomes vapor. The wax, when it is burned, it produces a flame and rises up in the form of vapor. Okay, that that happens when a candle is burned. Okay, when a wax candle is burned, the flame is produced and the vapor rises up in the air. Okay, coal on the other hand, it does not vaporize. Coal does not turn to vapor and it does not produce flame also. Okay, it does not produce flame also. Coal when burned, it just produces heat. Yes, heat it does produce. Okay, but flame, no. Okay, heat it will produce, but flame it will not produce. We will see the composition of a flame. Okay, we will see the composition of a flame. I will show you one diagram in English. Just a moment. You can see the three parts of um flame. Okay. the outer zone, the outermost zone, which is blue in color, okay, known as the zone of complete combustion, okay, zone of complete combustion, where full burning effect is happening, okay, combustion is fully happening. Middle zone, called zone of partial combustion, which is yellow in color, and then the inside part is there, innermost zone of unburned wax, okay, wax vapor, which is black in color. This, if you have seen that the wick is there, which turns first it is white when the candle is, you know, when the candle is unburned, and after the candle is burning, it turns black in color. Okay, it is black in color. So this part is the least hot. Center part is the least hot. The outer, that is the middle part, is moderately hot, and the most outermost part is the hottest. Okay, the outermost part is the hottest, the middle part is moderately hot, and the centermost part is the least hot in a flame. Okay, so this is your composition of a flame. Okay, this is your composition of a flame, and this is your candle flame diagram. Okay, if you want, I will send this diagram in the group so you can prepare. Okay, yes, Johanna.
Will this diagram come in the exam?
It may come in the exam. It is not one of the very important ones, but it may be asked when you are asked to tell the parts of a flame. Okay, so diagram can be asked, but it is simple. It is a simple diagram. You can prepare it. Okay. Now, let's come back to the lesson. You can read activity 10.9 and 10.10 as homework. Okay, 10.9 and 10.10 as homework today. Please get that over. Now, fire function, a very good and important concept. Okay, fire function. Have you ever seen firefighters, you know, using the instruments to put out a fire? Never seen that, or maybe no. That's okay. If you haven't, maybe you've seen it, seen it in a movie somewhere. Okay. So now, you must have seen or heard of fire breaking out in homes or shops and factories due to the carelessness and faulty equipment. Okay, maybe the carelessness is there, or maybe some equipment is faulty. And we have learned that there are three important requirements for combustion, for burning, that is fuel, air, and heat. Fire can be controlled by removing any one or more of these requirements. Okay, we will see how you can control a fire by removing the things which make a fire. Okay, which are needed for a fire. How it can be done. Okay, it is quite difficult to remove fuel from the site of fire. Okay, the material which is burning now, it is very hard to remove that material from the place where burning is happening. So we do some other two things. What are they? Number one is we cut off the air supply, oxygen supply. Okay, because oxygen is what keeps the fire burning. Air is what keeps the fire burning. So we cut off the air supply. Okay. How the supply of air can be stopped by covering the burning solid fuel with soil, sand, and a blanket. Okay. Everything, extinguishing the fire by putting sand on it, soil on it. Okay. Why? Because sand or soil cuts off the air supply from the burning thing. Okay, it cuts off the air supply from the burning thing. Now, when a person catches fire, what you should do is you should lay a blanket out and roll them in a blanket fully. Okay, cover them in a blanket and tell them to roll on the ground. So what happens is that it cuts off the fire supply. Okay, it cuts off the fire supply. Sometimes in people's homes, cylinders catches fire. Okay, gas cylinders. We all have gas cylinders in our home. So when gas cylinders catch fire, what you should do is you can take a blanket, okay, and cover the gas cylinder, wrap it up totally. Okay, I've like saw a video on it, and it cuts the gas supply and the fire extinguisher. Okay, or some people just wet a blanket or wet it totally and wrap it around, or just wrap it around the fire cylinder. Okay, so that cuts off the air supply, and then the fire extinguisher. Okay, now the second is by cooling the combustible by cooling the combustible material below its ignition temperature. Okay, cooling it below the ignition temperature. Cooling down the thing which has gotten fire below its ignition temperature, okay, below the point where it will catch fire. This prevents the fire from spreading. Okay, water vapors also surround the combustible material, helping in cutting off the supply of air. Okay, cutting off the supply of air. Water, you must have seen the firefighters using big pipes to spray water over a fire. Okay. But when it is done, when this is done, when wood and paper are on fire, or maybe a building is on fire, and the reason is not electricity. Okay, the reason is not electricity. If the fire is due to electricity, never put water. Okay. If fire happens due to electric short circuit, maybe a short circuit in an electricity pole, or maybe in one of your switchboards or anything, we will not put water in it. Why? What's the reason behind this? The reason is that the water is a good conductor of electricity. Okay, water is a good conductor of electricity. So if you put water in a place where electric fire is there, the water will flow to the ground. If any person walks in that ground, he will get an electric shock. Okay. Anybody who comes near that water accidentally steps in the water, touches that, okay, gets in contact with that water, the water becomes charged. Okay. When water comes in contact with electricity, the water becomes charged. Okay. And when a person gets in contact with this water, that person may as well get an electric shock. Okay, so never put water on fires caused by electric short circuits and all. Okay, now if electrical equipment is on fire, water may conduct electricity and harm those who are trying to put it off. Water is also not suitable for fires involving oil and petrol. Okay, if the fire is due to oil and petrol, sometimes what happens, oil spills, and if somebody throws a cigarette or a matchstick near it, it will light up. Okay, all of it will come on fire. All of it will catch fire. So that is oil and petrol. A fire is caused by oil and petrol. Water we should not use. Why? What's the reason? Because water is heavier than oil. Okay, water is denser, heavier than oil. So it uh, sinks below the oil, and the oil keeps burning on top. Understanding? Because water is heavier than oil, it sinks below the oil, okay, and the oil keeps burning on top. I want you to do one experiment at home today. Okay, I want you to do one experiment at home. Take uh take some water in a small container, maybe a little bowl, okay, just a little bowl, and fill it with water. Okay, take a little bowl and fill it with water. Then take 1 teaspoon of oil. Okay, 1 tablespoon of oil and put it in that water. Okay, don't take more than 1 tablespoon. Just 1 tablespoon or a little less, half a tablespoon is also fine. Okay, half a tablespoon of oil into the water. What you will observe that the oil will float on top of water. Do it and see. You will see that the oil will float on top of water. Why? Because oil is lighter in density compared to water. Okay. So in case this oil catches fire now, and we try to extinguish it with water, water will settle beneath the oil and the oil will keep burning on top. Okay. Oil will keep burning on top. So we have to cut the air supply. Okay, we have to cut the air supply. Now, what happens? How do we extinguish this if we cannot use water? How can we cool it down? If water we cannot use, you're saying, then how can we cool it down? Carbon dioxide. Okay, carbon dioxide is the way through which you can cool it down. We will talk about it now. Now, for fires involving electrical equipment and inflammable materials, when we have electrical fires and fires, petrol oil fire, CO2 is the best extinguisher. Okay, carbon dioxide is used. Now, carbon dioxide, what it does, it covers the fire like a blanket. It covers the fire like a blanket. Since the contact between the fuel and oxygen is cut off, the fire is controlled. Okay, the fire is controlled. Now, listen to this carefully. Oxygen leads to burning. Carbon dioxide does not. Okay. Oxygen present in the air will lead to burning. Oxygen causes burning. Carbon dioxide does not cause burning. Okay. It is used for extinguishing. CO2 for extinguishing, oxygen for burning. Okay. Now, these red cylinders are to get the supply of carbon dioxide. Okay. Carbon dioxide is stored at a high pressure uh, as a liquid in these cylinders. Okay. Uh, compressed high pressure liquid form and stored in this cylinder. Okay. When released from the cylinder, they expand a lot, expand enormously in volume. Okay. When we release CO2, it will expand in volume and cools down very quickly. Okay. So that brings down the ignition temperature and covers the burning material, cutting the oxygen supply. Okay. Brings down the temperature of the fuel. That is why it is the best fire extinguisher. Okay. Um, Fire extinguishers, red fire extinguishers are the best option. If the fire is, you know, electric fire or oil fires or petrol fires, then we have to use fire extinguishers. If it is a normal fire, okay, wood or paper, normal fire, then we can use water as an extinguisher. Okay. And if like it is a thing such as in our home, okay, maybe a cylinder fire, blanket is the best option. A thick blanket. Okay. Blanket is the best option. So that is there. I want to show you that video that I saw for the cylinder fire. Just see that. Okay. Check this out. This video is in Hindi. Okay.
गैस सिलेंडर में आग लगने से कई लोगों की जान चली जाती है। तो दोस्तों अगर सिलेंडर में अचानक आग लग जाए तो उसे पानी या मिट्टी डालकर बुझाने की गलती ना करें, क्योंकि जब तक आग का एयर कांटेक्ट नहीं टूटेगा आग नहीं बुझेगी। पहले जान ले अगर पाइप पर आग लगी है तो तुरंत गैस रेगुलेटर बंद करने की कोशिश करें। वहीं अगर आग नोजल या रेगुलेटर पर लगी हो तो गीले सूती कपड़े से सिलेंडर को ढक दें ताकि हवा का संपर्क टूट जाए और आग बुझ जाए। लेकिन अगर आग बेकाबू हो जाए तो अपनी सुरक्षा का ध्यान रखते हुए तुरंत फायर ब्रिगेड को कॉल करें।
Okay, so what they have explained is that if the fire is on the gas pipe, okay, the fire is leaking out through the gas pipe, there is a regulator that is present on the cylinder. You just have to turn that on. Okay, if the fire is coming out of the pipe, is to turn off the regulator. And if it is coming out of the nozzle of the cylinder, okay, or the whole cylinder is on fire, that time you have to take a wet blanket and all, maybe a wet bed sheet, and wrap that up quickly. Okay, so that will cut off the air supply and it will put off the fire. Okay, it will put off the fire. But if it is a bigger fire, it is spreading, then call a fire brigade. Okay, so that is like the if you think that it is getting out of hand, then we have to call emergency service. Okay, now we will talk about fuel. Hope it was clear. Hope everything was clear. Any questions? Any questions? No. Okay. All right. So that is important that we should always have basic knowledge in what to do in emergency situations. Okay. So you should also know what numbers to call. Okay. What is the number for the fire department? What is the number for an ambulance? What is the number for the emergency health services and all? Okay. You should memorize it. If you have not memorized till now, please after class memorize it. Okay. We don't know when we, okay, God prohibits, we or somebody else may need it. Okay. So memorize all the important emergency numbers. Okay. And that's it. That's it for the class today. Tomorrow we will finish up the last concept, the last topic that is in the chapter, theory. Okay. Tomorrow we will talk about, okay, tomorrow we have a science test, do we? Or a math test. It's a science test, right?
On the sixth chapter.
Um,
Science
so
test.
science test, huh? Yeah. Science test we are having. So sixth chapter science test is there. So we are not meeting for the science class tomorrow. We will only meet for maths tomorrow. Okay, so Monday we will meet and Monday we will finish the last topic from this chapter. Okay.
Ma'am,
Yeah.
will there be maths class tomorrow?
Will there be a math class tomorrow? Yes, I'm thinking to take a math class tomorrow, and I'm also thinking to give you time and homework. I will let you know. Okay, I will update you. I will let you know if I give you a day to finish the test and the math homework that I've sent you. Okay, so Niyaz will give you a complete of tomorrow. All right, assignment, the math assignment, and the test. So I'll update you. I'll let you know. Let's see after the class. Okay. So 5 minutes break for you, 5 minutes break, and then we'll start with the next class.
Ma'am, is there math class today, ma'am?
Hello, Joshua. Yes, we are about to start. Videos on, please, all of you. Okay. And I sent you yesterday's lecture video, Joshua. Did you watch?
Yes, ma'am, I did. Ma'am.
Okay. So, yesterday we started with the circuits chapter. Okay. Yesterday we had started with the circuits chapter, and we will continue that today. We will continue the lesson today and learn some new concepts about a circle. Okay. Now, first, let's talk about a sector and a segment. Just a minute. Yeah.
Ma'am, should we copy this?
Yes, I will. You have to copy this.
Okay.
Yes. So we are talking about a sector and a segment. Okay. Now I will mark a center point on the circle first. Okay. I will mark a center point in the circle. Now what I will do is I will mark two radius from the center anywhere in the circle. Okay. Two radius from the center anywhere in the circle. Alright. So what is this? What is this? This is known as a sector. Okay. This is known as a sector. This portion is called sector. What about this portion? What about this portion? This is also called sector. Okay. It is also called sector. Okay. When the chord divides the circular region into two parts. Okay. When the radius is and the chord divides the circular region into two parts, each part is called, oh sorry, 1 second. Yes, when the radius divides the circular region into two parts, each part is called a sector. Okay, radius. When the radius or when two radius or two radii divide the circle into two parts, each part is called a sector. Let me know when you're done writing. and then making the diagram.
Done, ma'am.
Ma'am,
Yes. Yes.
for me, you only wrote till when 2 radii divides the circle into 2p. That's all I see.
When two radii, okay, radius, or radii you can do. Both have the same meaning. Okay? Both have the same meaning. Either you can use radius or radii because I'm talking about more than one radius. Okay, we have used the word radii. All right, so you can do two radius or two radii. That have the same meaning. The diaries. Okay. Okay. So done yours. Shall we move on to now segment? Okay. So this is sector. Now talking about segment. Done writing, Johanna?
Give me 1 second, ma'am.
Yeah. Okay.
Done, ma'am.
Now see. Now we will make segment. Okay. Now, what's the difference between the sector and a segment? Okay. Sectors are made up of radius. Segments are made up of chords. Okay. Sectors are made up of radiuses, whereas segments are made up of a chord. Okay. I will put a chord. First, I'll mark a center point. Okay. And then I will put a chord anywhere in the circle. Okay. I have marked the chord. Let's name the chord AB. Okay. AB. Center name AB. And now, what is a segment? This part is a segment, and this part is also a segment. Okay, this part is also a segment, and that part is also a segment. Okay, so this chord divides this circle arrangement into two parts, and each part is called a segment of the circle. Hope that is clear now. Now, what about diameter? What about the diameter? And because when we said that diameter is also a chord. So when the diameter converts, sorry, you know, cuts the circle into two parts, divides the circle into two parts. Then also are they called segments? They are segments, but that time because the diameter because the diameter passes right through the middle, right through the middle. No? Okay. It divides the circle into two equal parts that I explained you because the diameter passes through the middle. And because it is divided into two equal parts, we call them semicircles. Okay, so semicircles when they are divided by diameter chord. Okay, when they are divided by any other chord, then segment. Okay, and when it is divided by radius, then sectors. Okay, sectors, segments, and semicircles. Understood? So, Prithviraj,
Yes, ma'am.
done writing?
Yes, ma'am.
Done, ma'am.
Okay. Now, where were we? Now, there is one more thing. Okay, one more thing. When a circle is drawn in a plane, okay, when a circle is drawn in a plane, it has three parts. This is just very simple and in your book, so I'm covering it. Okay, when a circle is drawn in a plane, it has three parts. Okay, this interior part of the circle is known as interior. The plane on which it is drawn, okay, the plane on which it is drawn, this part is known as exterior. And then there is the boundary of the circle itself, which is called the circle itself. The circle, yes. The circle has, when it is drawn in a plane, it has three components: the exterior, interior, and the circle itself.
Ma'am.
Yes, yes, Hannah.
Ma'am, shouldn't apart from the interior and the exterior, shouldn't the circle be called the circumference?
Shouldn't the circle be called the circumference? Yes, the boundary of a circle is called circumference. That is true. Okay, but in a plane figure, when we are drawing it, we can just refer to as a circle. Okay, we can just refer to as a circle. But yes, the boundary of a circle is known as circumference. That's right. Okay. Now, some questions we will do. Okay, some questions we will do, and I will give you one question to try out. Okay. I will give you one question to do. Done making this diagram.
Yes,
Yes.
ma'am.
Okay, so solve this question and tell me. First, we make this circle. You can draw this with me. Now my question is, you have to tell me what is the name of the center, what is the name of the radius, which one is the, if it has a diameter or not, or which one is the diameter, which one is the chord, which is the arc, which is semicircle. Okay, that is all if it has a semicircle. So those are the questions. So first
Ma'am?
question, what is the center? Yes, Abhijit.
Point P.
P point is the center. Yes, that's right. What is the chord?
AB, ma'am.
AB,
AC and CB.
AC, sorry, AB, AC, BC are the chords. Okay. What is the sector? What is the sector in this?
Ma'am, your voice was breaking, ma'am. Could you?
Yes. I'm asking, what is the sector in this? Sector. Which one is the sector in this?
Ma'am?
Yes, Abhijit.
AB, from A to P and P to B, that's the sector.
Yes. This is my sector. ABC, you can say. Okay. ABC sector. Now, who will tell me what is the radius? Radii.
Ma'am.
Yes, Anna.
Ma'am, PA and PB.
PA and PB. Yes. PA, PB, radii. What is the arc? What is the arc in the circle? Or what are the arcs in the circle?
Ma'am, CB.
CB. Yes.
CB.
CB.
Ma'am, CB, CA and AB.
CB. CBA. AB. AC. ACB. Okay, what all I'm writing? CB means this portion. CBA means this portion. Okay. AB means this portion. Okay, then AC means this portion. ACB means this portion.
Ma'am, you're drawing the arcs.
Yeah, these are all the arcs. Okay, these are all the arcs. So when you're writing arcs, you can write the symbol above them. These are all the arcs. These are all the arcs. Okay. Then if I join if I make one line like this,
Diameter,
and then
ma'am.
ask, yeah, diameter. It's not aligning with the center point, so sorry. It's a little bit off the center because I'm not measured in it. Okay, you can just make it diameter. Okay, because it is going through the center point. Diameter. Okay, then semicircle also. If I make it like this, okay, it will divide the circle into semicircle. All right. So these questions like this can come. It may give you a diagram and ask you that now identify the part. Okay, so like this you have to do. Like this you have to identify the part. Now I'm clearing the screen. Okay, and we will do some questions based on diameter and radius. Okay, hope you're done writing. Hope you're done writing.
Done.
Done, ma'am.
Okay. Joshua, questions like this I will send as homework. Okay. Questions like this I will send them as homework to you. All right. Many questions are there. We'll give you homework. Now, okay. All right. So, in a circle, radius is equal to 3.5 centimeters. Okay. Radius is equal to 3.5 centimeters given in the question. Who will tell me what will be the diameter?
7 cm, ma'am.
7 centimeters. Why? Because diameter is equal to 2 into radius. Okay. Diameter is equal to 2 into radius gives us 7 centimeters. Now, in another question, diameter is equal to 16 centimeters. Who will tell me what will be the radius?
8.
8 centimeter.
And 8.
Yeah. Why? Because radius formula is diameter divided by 2. Okay. Radius formula is diameter divided by 2. So 16 by 2 we will do, which is 2. Okay. So this is very simple. To calculate radius, we have to divide the diameter by 2. To calculate the diameter, you have to multiply radius with 2. Okay. When we will get to area and volume question, I will teach you how to calculate the circumference. Okay. In this chapter, it is not there, but in the area chapter, area and all, we have circumference also, how to calculate circumference, how to calculate area, volume. We will see that, okay? Area and all. Volume, we don't have our circle, we have area, okay? And so on, we will see that, all right? So, that is all for radius and diameter. Now, one concept I want to cover. Okay, one concept I want to cover. Shall I clear the screen now?
Okay, ma'am.
Yeah. Now, see, the distance between the chords and the center. Okay, the distance between the chords and the center. For example, I will make a circle. Okay, I will make two chords in it. I will make a circle and I will make two chords in it. Okay, and I will make the center point also. Okay, I will make my center point also. Now, the question is that which chord is closer to the circle, center point, okay? Which chord is closer to the center point? How do you solve this? This question like this comes, and it asks you that in a circle there are two chords and this is O point. This is O point. Okay, we will name the chords also. AB and CD. Okay. And if the question comes, is AB closer to the center or is CD more closer to the center? Okay, so how to solve this? We will draw two perpendiculars from O to CD and AB. Okay, how to do that? You will take your scale and draw a line from O to CD and then draw one more line from your O to AB. Okay, you will draw one line from O to CD and another line from O to AB. What we have drawn is we have made perpendiculars. Okay, and these angles will be 90 degrees. The perpendiculars are always 90 degrees. Okay, so we will draw straight lines. Okay, now
Ma'am,
we will measure. Yes, Yeshua.
ma'am, exactly 90 degree, or can it be a few degrees to either side?
When you will draw lines, Yeshua, it will be 90 degree exactly. Okay, you don't have to measure it and draw. You can just take your scale and draw. Okay, you don't have to measure and draw this. But what you have to measure now is these two lines. Length of these two lines is what you have to measure. I'll name them M and M. Okay, so you have to measure OM and ON. Okay, you have to measure OM and OM. So when you will measure them, you will get that OM is bigger than ON. Okay, draw measure and see. Measure and see. You will get OM is bigger than OM. Okay, so now see, whenever we have the shorter perpendicular, okay, the shorter the perpendicular, the closer the chord is to the center. That's the thing. Okay, that's the verification. Okay, so since ON is smaller than ON, we can conclude that the chord CD is closer to center O than chord AB. Okay, means the shorter perpendicular one, the chord with the shorter perpendicular will be more closer to the center compared to the chord with the longer perpendicular. Okay, the one with the shorter perpendicular will be more closer compared to the one with the longer perpendicular. All right, that is how we can say which chord is more closer to the center. This is the verification. Okay. Any questions related to this?
And what is the code?
What is a chord? Any line drawn from any point on the boundary of the circle to the other point on the boundary of a circle is a chord. Okay. Any line drawn from one point on the circumference, that is boundary, to the other point on the boundary circumference is known as a chord. The one that passes through the center point is called diameter, and the other ones which do not pass through the center is called are just called chords. Okay, the one passing through the center is the largest chord, longest chord called the diameter. The other ones are just called chords. Okay. Okay. Now, okay, that's one verification then. We have one more verification, measurement of the angle that I have to do with you. Okay. And then, yeah. And then construction of a semicircle to a given centimeter. For example, I tell you to construct a semicircle with radius 5 centimeters. How will you do that? Construct with 6.5 centimeters. How will you do that? That is also have to teach you. So two or three topics from this chapter are still pending. Also, I wanted to discuss a math test paper I have been meaning to discuss the math test paper with you. Okay, so um, tomorrow, let's meet tomorrow, finish this chapter, and Monday, shall we discuss the math paper Monday? Is that fine? Yeah, discuss the paper Monday and finish the chapter tomorrow.
Yes, ma'am.
Yeah, so tomorrow we will meet, maybe half an hour, okay, to finish this lesson, and then tests will be given to you. Also, timing for tomorrow is 12 p.m., okay? Don't join at 12:45, Joshua. Just stay back after Harvey Sir's class. If you have a class of search, you can just stay back and we will start the math class at 12 p.m. And then after that, everybody else can do the science test. Okay? Homework I will send in the group
Ma'am,
today. Yes, Hannah.
ma'am, what is the science test due, ma'am?
Say again.
Ma'am, when should we send the science test, ma'am?
Tomorrow evening. It is best if you update the paper tomorrow evening or highest by Saturday. Okay.
Could you repeat
Ma'am, I
what you said about the test?
on
Uh,
Friday.
one by one, please. Yes, Hannah.
Ma'am, I might be busy on Friday. We have to go out.
Okay, so you can send by Saturday. Okay, you can send it by Saturday. Yes, Eva.
I can't really hear everyone.
You cannot hear my voice.
I've only been auditioned from the screen.
I cannot understand that, Eva.
Could you repeat what you said about the test?
Yeah, this class tomorrow at 12 p.m. Math class at 12 p.m. 12 to 12:30. 12:30, I will update the science paper and you can submit it by Friday evening or Saturday. Okay. Saturday is the deadline. Saturday is deadline. Saturday, by Saturday, I need everybody's papers complete. Okay. So Saturday is your deadline. And tomorrow we'll finish this lesson. And Monday we will meet and I will discuss the math test that I did last week. Okay. I will be discussing that test paper on next week, Monday. All right. So that's it. That's it for you all. And I'll see you then. Have a good day. Bye bye.
Ma'am.
Bye.
Thank you,
Bye,
ma'am.
everyone.
Thank you, ma'am.
Thank you, ma'am.
Nice to meet you.
Bye.